Hi everyone, Marcos Colon here, Head of Digital Content Strategy at MISTI. I want to thank you for joining us for this presentation that's part of our Vulnerability Assessment E-Summit titled Beyond OWASP 10 Vulnerabilities, sponsored by Security Compass. Now joining us today is Vishal Asthana, Director of Customer Solutions for Security Compass. Vishal has designed and co-presented the Secure Me Droid app at OWASP's flagship AppSec show, and he's also the chapter lead for OWASP Delhi for the last 2 years. He has over 15 years of experience in the information security industry, so you can see why today he's the perfect subject matter expert whose knowledge we can tap into. Now, as many of you know, the OWASP 10 is the standard first reference that many web developers receive if they're aiming to develop applications with security in mind. Now, we constantly hear that many developers aren't producing applications with security in mind, but the tide is shifting, and the OWASP Top 10 is a big part of that. Now, during today's presentation, Vishal will be discussing 3 vulnerabilities that don't fit into the OWASP Top 10 categories, but present just as much risk if they're present in web applications. Now, just keep in mind that slides are available with the content button. Just select Files in that lower left-hand corner of the screen. And to ask any questions, remember to use the green Q&A button. Now, I'm going to go ahead and hand it over to Vishal to kick things off for us. Vishal, thanks for being with us today.
Right, thanks for the introduction. So, yes, today I'm here to talk about a rather interesting topic, simply because OWASP Top 10 vulnerabilities over the years have gained a lot of traction in terms of popularity, and they get used quite a lot. And as mentioned by Marcos, my topic for today is to help you look beyond OWASP Top 10 vulnerabilities. Before I dive into the specific examples that I'm going to give today, I wanted to take a minute to talk about my current employer. I've been with them for a little over 4 years, and my current role is that of a Client Solutions Director, but I've also been on the practice lead side of things from an advisory standpoint in my previous role. In terms of Security Compass, the company helps build secure software and has been in this business for over 10 years, and we have like a large array of Fortune 500 clients that we service. We have 3 main lines of business, or the business units per se. The first one is software security services of various kinds. These could be tactical or these could be strategic. These are given as part of advisory business unit. The second one is a security requirements product, which is ASRTM, which stands for Application Security Requirements and Threat Management. And the product is known as SD Elements. It's already used by a large number of enterprises. And then the third business unit that we have is the training business unit, where we have a ton of e-learning courses, which is computer-based training, along with some instructor-led training depending on the needs of clients. The agenda for today, loosely, the first thing that I would like to touch on would be around OWASP's popularity in terms of why is Top 10 so popular, right? And once we cover that, I would move into, let's go beyond OWASP Top 10. The 3 specific vulnerabilities that I would like to draw your attention to today, which are equally dangerous as the OWASP Top 10 list, are race conditions, HTTP parameter pollution, also abbreviated as HPP, and server-side request forgery. And the way I'll be covering them today is by giving a brief description, followed by discussion of a real-world exploit, and then some tips as to how should you go about including these tests in your vulnerability assessment efforts. Finally, I'll cover a key takeaway, and you will hear this message. You've already been hearing part of this message when I started my talk today, and you will kind of hear this message throughout, and hopefully by the time I finish covering the 3 vulnerabilities, you'll be able to see why the suggestion is coming through this talk. And then finally, I will wrap it up by covering the avenues through which Security Compass can help you with your vulnerability assessments. And if you are interested, then how do you sort of proceed to the next stage and who to contact, et cetera, et cetera. All right, moving on. OWASP as such stands for Open Web Application Security Project. It's a volunteer-driven community across the world. They have chapters all over geographies. They have conferences which are, again, all over geographies. Now, many years back, OWASP came up with a top 10 list. The question is, when they came up with the top 10 list, it was intended on being an awareness document. But over years, what started happening is that organizations started using that as the baseline for their security efforts, right? So it quickly turned from an awareness document to something that became like a passing, something that would determine whether you get a passing score or not, right? So why is OWASP Top 10 so popular? So we looked at some research, we did our own research, and we also looked at a 2015 paper from SANS. It was a white paper that talked about the state of application security. And we found that it nicely explained some of these reasons, and these reasons make logical sense when you think of it. So it's one of those connect the dots kind of thing, right? So one of the very first things that OWASP Top 10 does is that the list itself is very short and simple. So the concern areas are only 10. There are not 100 concern areas. There are not 50 concern areas. It's only 10. So what that does for anybody, if you think of a web developer or a web development team, what that does for them is to give them something really short that they could focus on, versus expecting them to meet with, let's say, 50 or 75 or 100 different requirements, or it might be the various security vulnerabilities. Expecting them to guard against each one of them may not be very intuitive, right? So the shortness and simplicity got it very popular. Most static and dynamic analysis tools report OWASP Top 10. They have inbuilt reports which will say, how are you faring against the OWASP Top 10? What that does is then when it comes to compliance, things become a lot easier, right? And the third reason is that OWASP Top 10 is referenced in regulatory standards such as PCI. If you are into payments, then you have to be compliant with payment industry standards. So this is referenced very regularly in such standards. And these three reasons over the years have made OWASP Top 10 way more popular than many of the other initiatives that have been out there, right? So just to keep this at the back of your mind, because it's likely that you already have seen some of these reasons. It's probably one or more of these reasons are probably already applicable to your current environments, which is fine. OWASP Top 10, every few years, what they do is that they would go back and they would look at what kind of changes have happened on the technology side. And based on those changes and on the vulnerability landscape, should that list be updated? So every 3 to 5 years, you will find that OWASP Top 10 list keeps getting updated. Matter of fact, a couple of weeks before this webinar, OWASP formally released its Top 10 2017, right? And I would not be covering each one of the vulnerabilities in there because that's not the focus of this talk. But the interesting part to note is that even in the latest list, which incorporates all the advances in technology in terms of, let's say, nowadays there's a concept of single-page web applications or of microservices. So these concepts were looked at, OWASP themselves, as in whoever contributed to the project. Remember, this is community-based. This is consensus that's across the community, and community is not restricted to any geographies around the world, right? So despite taking all of that, the top 10, the latest and greatest top 10 list still doesn't take into account the dangers or the vulnerabilities that we are going to talk about today, okay? Injection is still featuring as the number one issue that gets seen in terms of the danger that it presents. Authentication issues, again, extremely dangerous. Features as the next one. Sensitive data exposure. Nowadays, yes, with all the privacy regulations and stuff also coming into picture, sensitive data exposure can lead to a lot more, right? So it's not just restricted to, oh, well, I lost the data. Now something bad's going to happen. That something bad can translate into a large list of potential impacts, right? XML, external entities, is something that got added in 2017. Broken access control is very much there in the list, and security misconfiguration. So a lot of issues usually tie back to, or a lot of vulnerabilities that are seen in web applications, they do tie back to security misconfiguration issues. Cross-site scripting. Most people who have embarked on their journey of vulnerability assessments or about knowing what application security entails and the kind of vulnerabilities would know that cross-site scripting and injections have been there forever, and they still pose the highest amount of risk, or in terms of the dangers that they pose to web applications. If they are there, the dangers are still there, right? Then insecure deserialization, that's the 8th issue. And then you have using components with known vulnerabilities. And this especially is applicable to third-party components, which often get used in a development environment. The reasons could be multiple. You don't have to reinvent the wheel for everything. So it just makes, a lot of times it makes better business sense to reuse an existing component. And then last but not the least, which is a new addition for 2017 OWASP Top 10, is insufficient logging and monitoring. So a lot of times you have web applications which are developed, they are rolled out to production, they are online, there are things that are happening on the web application, some of them by valid, legitimate user, and then there are things which are being attempted by attackers. Many times just the amount of logging and monitoring is not sufficient to capture a lot of those things, especially when things go wrong. Okay, so if you see that as such, if you look at OWASP Top 10 as a list, it's fairly good, right? So it's fairly broad. It covers a wide array of issues, but the point is that this is not it. And these wide array of dangerous issues are good to know that, yes, this is fantastic. If I am a web developer, I need to look at this to get a good holistic idea of what I need to be doing. Problem is, that's where people stop. And people, and when I say people, I mean organizations, end up considering OWASP Top 10 as a standard, as a guideline. Whereas if you go on OWASP Top 10's website, you will find even they themselves have recommended that this is an awareness document which should be a first step. What does that mean? You should not be stopping there, right? So with that said, here are the 3 things that I'm going to talk about. I'll describe them, I'll give the exploit, and I'll share some ways to test them. The first one being race conditions. There is a CWE number associated with that, which is 362. For those of you who are familiar with CWE, you already know that this is another database, but which is much, much bigger than OWASP Top 10. It's also public. It's called Common Weakness Enumeration, and it has over 700 software weaknesses which go beyond just web applications. More often than not, you will find that if you are, let's say if you are using tools or scanners for your vulnerability assessment efforts, or if you're getting some manual verification done, or a combination, you will find that the reports that get generated will often cross-reference, even if it's an OWASP Top 10 report, it will cross-reference the underlying security weakness. So when I say that there is a cross-site scripting vulnerability, what's the underlying weakness for that. And that underlying weakness would translate back or map back to a CWE number, which is, hey, I took untrusted input from the user, but guess what? I didn't properly sanitize it before using it as output on a web page. So that would be the underlying weakness. So the reason to share this for the vulnerabilities that we are talking about right now, like race conditions, is twofold. One is that you can take it back and sort of read more about that if you choose to add this to your vulnerability assessment efforts. Second is even to get an internal discussion going with your other stakeholders. It always helps to give a public reference versus saying, hey, we think that race conditions would be an equally dangerous vulnerability. Well, here is substantiating data for that. And then additionally, you can see if there is a way to configure this in your scanners, to check for this in your scanners, this particular CWE, or you can get this added to your manual efforts. Okay. So for race conditions, essentially what happens is that when the timing of one action impacts some other action, essentially events may happen out of sequence. And when events start happening out of sequence, needless to say, there could be some sort of anomalous behavior. So let's take a quick example. What happens is that if I am a developer, I'm going to make an assumption. If you see on the bottom left of the screen, there are two processes. The first one, intuitively, if you just look at it, it seems that the first process is longer than the second one. So which means the process Y, which is the shorter one, will finish faster, right? It should finish faster versus the first process. This is where I have made an assumption about the order of operations. And this becomes extremely dangerous in web applications which by design are asynchronous, right? So in such environments, when you make this assumption, what really happens is what you see on the right side of the screen, which is a CPU or a processor might start with the shorter process first, but then somewhere in the middle, it jumps to whatever balance the processing or sort of seeing how to time. The CPU jumps and ends up finishing process X completely, not in parts. And guess what? Process X, which was supposed to finish later than process Y, it actually finished before that. And then CPU jumps back and continues with process Y. So when me as a developer who made that assumption that process Y will finish before process X, my assumption has gone for a 6, right? In reality, something else has happened. How this affects or how these race conditions become dangerous is that if you look at shared data that is being accessed or modified by multiple sources simultaneously, it becomes extremely dangerous because, again, it's the assumptions which have basically gone wrong. Let's look at a real-world exploit. There is someone, a researcher, who very recently ended up draining Bitcoins through a bug bounty program. At the bottom right, you'll see the source. So there was a researcher submitted a valid bug. Obviously, the person is a security researcher, so as part of the research, he or she would be keen on trying to find a security bug and submitting it to a bounty platform. Did so for Cobalt.io and was supposed to be paid out in Bitcoins. All this is fine. But because the researcher is a researcher, which means has the attacker mindset, said, let me submit the payout URL multiple times. Let's see what happens, right? Guess what? Because of the underlying assumptions that were made, race condition did come into picture. And the person, the researcher, ended up receiving multiple payouts. How did that happen? Well, regarding the payout, the logic was assumed to be similar to essentially a 3-step process. The first step was let's say I am the one who's submitting a payout URL. The logic was, well, you received the payout URL. Is that valid? Yes, it's valid. The system says, okay, then you need to send whatever were the allocated Bitcoins to the destination wallet. And then after I've done sending that money or Bitcoins to the destination wallet, I mark the payout URL as invalid. That's fair enough, right? Again, from an assumption perspective, all three of them should be happening logically. But what the researcher ended up accomplishing is that by submitting way too many requests simultaneously, all of them were for payout. The researcher had the application go to step 2, which means send the Bitcoins to this destination wallet multiple times, even before the application could reach step 3, which means even before the application could say, oh, hold on, I've already paid this guy. I should not be paying this guy anymore. Just exploited that little window, very small window before step 3 happened, and then at that point, the check in step 1 was still valid. Again, why? Because assumptions were made and a race condition was exploited. So let's talk about testing for race conditions. Give you some ideas and tips that you can go back and investigate further and see if you want to sort of put that in your vulnerability assessment efforts. Identify all the shared data. This is key. This is the first step. And shared data means, by definition, shared data would mean any data that is used by multiple resources, right? So you have to identify that. Identify where that shared data is accessed across the systems. How does this really map out? Again, don't make assumptions. Find out where that data access is not synchronized. And this also ends up being a very key thing. Again, if you go back to the most common architecture for web applications, you'll find that asynchronous goes hand in hand with web applications. So where is synchronization not really featuring in and the data is still getting accessed? And then you make a whole bunch of requests. Why? Again, go back to the real world exploit that we gave or that we just talked about. When you make a whole bunch of requests, you will come to know whether your application is suitably handling them or whether the application is functioning as per assumptions and breaking. You can also use the help of certain very good tools that are out there. One of them is called Race the Web, RTW. It's an open source tool. It's built specifically to easily test for race conditions. And it also happens to have an accompanying vulnerable web application. If you want to have your testers practice, let's say if you have some internal test team, you want to have them practice race condition testing, that this is what can be used. You can use Burp Suite Intruder. Burp Suite is also a tool that's used for security testing. It's not really a scanner, it's more of a proxy tool, which has a whole bunch of plugins. And what I mean by that is that when you have it in your environment, you can study the requests, you can study the responses, you can use some additional add-ons or modules that are there to automate some of the testing efforts and so on and so forth. All right, moving on. The second one that I would like to talk about today is HTTP parameter pollution, abbreviated as HTTP. Again, I've given the CWE number for the reasons that I shared previously for race conditions. It's CWE 235. What happens here is that you have the situation where multiple HTTP parameters are supplied with the same name, but with different values, right? So again, this is more of thinking how to abuse the functionality, right? So that's something which is key when you're getting vulnerability assessments done or when you're doing it. So all right, so let me use the same parameters, but I'll give them different values. And the effect is that the parameter values get overridden, which again can result in anomalous behavior by the web application. It can be the same request type, could be a GET, POST, or whatever, or especially in the case of a POST request, you may have URL parameters and body parameters, which are sent in the same request. It's also called cross-channel pollution. And channels in this context is it could be your URL, could be your requests body, could be your cookie headers. What you see on the screen now is just an example to show how the parameter values are interpreted differently by different technologies. So I'm not going to cover the entire table, but this is just to give you an idea that if you look for an ASP.NET system that uses an IIS web server, and the example, it will interpret parameter values very, very differently than if you go all the way down to, let's say, a Python, right? And how Python would interpret the values. So for ASP.NET, if you see the overall parsing result is that all occurrences are actually taken into account. Whereas if I go down to, let's say, Python, it becomes an array. Or if I go to a JSP or a servlet, it only looks at the first occurrence. So based on the technology, contrary to what you might be assuming or your developer might be assuming, based on the technology, parameter values get picked up differently. They get interpreted differently. Again, tying back to assumptions piece. Let's look at a real-world exploit. SQL injection. SQL injection, so which is essentially getting access to the database or doing damage to the database using HPP. Sounds interesting, sounds funny. Well, it's very well doable. Check out the example URL that I've given on the screen that you see on your screen right now. If you see that I've only reused the parameter Q multiple times. I've basically used it 5 times. And each time that I use it, along with that, I've kind of put my SQL query and I've tried to harness certain inbuilt features of how this would get interpreted at the database level, or especially in this case at the application level. So if you look at this long query, essentially the result is that through this parameter Q, I have executed a SQL query that says select name and the password from the users table. And how did I do that? Well, guess what? And Q equals to would equate to a comma, and anything out left and right of that is a comment. So I say, hey, so to remove the commas, let me just split. And how do I split? I'll use SQL comments. And when I'm able to use SQL comments, that's how I'm able to achieve this, right? And in SQL, I know that comments also act as spaces. Brilliant. Now I know what I have in order to craft my attack. How do you test for HTTP or HTTP parameter pollution? Well, simple. You append existing parameters with different values. So in this example URL below, you will see that the parameter ID has a valid value of 1, 2, 3. At the same time, ID I've given it a value of 321. And I'm not concluding anything. I would send this and I'll see how the application behaves, which means how does the underlying SQL interpreter, what does it do with it? Does it do anything? Or how does it handle different values given to the same parameter? So this is applicable for any HTTP request. And yes, you can append one of the parameters to the end of the query, and you observe the resulting behavior. And when you observe, you will see, okay, I gave 2 values. The first one was 1, 2, 3. The second one was 3, 2, 1. Which one was actually acted on? And was it the one that I expected, or is it different? And if it's different, that means there is something that's gone wrong with the assumptions, right? So some assumption was made and something has not worked with that assumption. You could automate with Burp Suite, and Burp Suite has this functionality where you can say, let me match the request that contains parameters, which is essentially an intercept rule. You could have intercept rules itself with Burp Suite Intruder. That's also one of the components or a plugin that you'll find in Burp Suite. You investigate sources. What does that mean? Sources is essentially form fields. The fields could be people fill in something and they want to search for something, that's a field, or it could be a login field, right? It could be admin or administrator page identifiers. How does that work? Well, very simple. If you see in the URL here, you say page is equal to 1 could be an admin access only page, and page is equal to 1, 2, 3, 4, 5 could be a world readable page. So you investigate more by intercepting such post requests and adding these parameter values and seeing what happens, right? All right, so we move on to the third one and the last one for this particular talk, which is server-side request forgery. Again, the CWE number is 918. Essentially, an attacker can force a server to perform requests, so forge requests on their behalf, which is why it's called server-side request forgery. It's commonly used to bypass firewalls to reach internal network. Often an application attack becomes some sort of network attack. It's very useful when you want to do enumeration and recon or reconnaissance in network testing or attacks. And as an attacker, I can hide my source IP. It can actually even be leveraged to get some sort of cross-site scripting via whatever content gets returned. And it's often introduced to bypass what's known as same origin policy. Let's look at a real-world exploit. So you can query AWS metadata. There is an endpoint that, in this case, the researcher found, and that endpoint was only supposed to load images, which if you see on the top right of your screen, it will say URL is equal to, but this was easily bypassable by giving an extension of an image, but changing everything before that. So in this case, the researcher actually ended up finding or saying, hey, I'll use the same parameter, I'll give the extension of an image, but inside that, it will not be a real image, it will be something that redirects to my site, or it could be, in this case, it was an XSS or a cross-site scripting payload. You can query this IP address, 169.254.169.254, to pull metadata. And then how would you do that? Here is an example. Again, you use the same parameter called URL, but now, because you know that you can use this IP address to pull data, you go ahead and do that, right? And there is, in fact, a guide, a publicly available guide that actually tells you, hey, all about the kind of metadata that you could look for. How would you test for the request forgery? Well, again, Burp Suite has something known as Intruder, works really well. You could use Burp Suite's Collaborator for external resources if you do not happen to have your own. And when you're doing it at a manual level, you could see, hey, is the URL provided in the request? If it is, you try and change it to another URL. You could try and change it to a loopback address or some local IP, maybe a different protocol or maybe a different port, right? So with that, I'm done with coverage of the 3 vulnerabilities, and I hope that you would see that OWASP Top 10 as such is really great start. Please don't get me wrong that the intent of this talk is not to say that stop using OWASP 10. That's a solid start. But don't make it your baseline. Don't make it your passing score. Think of that as a starting step, right? And then add these 3 vulnerabilities to the mix that we have talked about today, which is race conditions, HPP, which is parameter pollution, and server-side request forgery. And to wrap things up, how can we help? And when I say we, I'm talking about Security Compass, my current employer. There are a whole bunch of ways in which we can help. The very first thing is that if you're also keen on knowing about the defenses and mitigations for the 3 vulnerabilities that we discussed, this same talk was first presented in a much detailed manner, which covered defenses and mitigations at NOLACon in 2017. So I've given you the YouTube link for that if you are keen on looking at the defenses and the mitigation side. And at that time, OWASP Top 10 2017 was a release candidate, so we did cover it briefly at that time, but in this talk, we've actually covered it formally because it's been released officially. The second thing is you can, if vulnerability assessments and pen tests is of interest to you from a third-party perspective, this is something that we offer as one of our professional services through our advisory business unit. The third thing is we do help companies convert vulnerability assessment data into security requirements. This is through our product called SDE Elements. And then finally, we also have training programs, which is a combination of instructor-led training, one of them being OWASP Top 10, which should also re-emphasize the fact that we support what OWASP Top 10 offers, which is why if somebody wants to get their team trained through an instructor-led module on OWASP Top 10, we definitely do have that. And on top of that, we have a total of 28 courses, of which 26 are for architects, developers, testers, and 2 of them are specifically for testers, which is software security testing and software security acceptance. So if you want to arm your QA teams to test more effectively for software security vulnerabilities, how do you do that? These are the kind of e-learning courses that could help. If you want to go and help or give the same kind of knowledge uplift to the architects and the developers and testers, then we have this whole catalog of 26 additional courses. And with that, I am done. Here is my contact information. If you need any further information or you want to brainstorm, I'm reachable at vishal@securitycompass.com. I'm very active on LinkedIn as well. So I hope this made sense. And over and out for now.
All right, thanks for that great information, Vishal. Now we're going to go ahead and jump into some questions. The first one I have here is, why did you specifically choose these 3 vulnerabilities?
That's a good question. So when we were doing our research about the topic itself, we found that OWASP Top 10 tends to get used as a de facto list or an awareness document. And what we were looking for was not to prove anything against OWASP Top 10, but rather let people know that do not stop at just the top 10. It's a good first step, good to get started, good to know that these are the 10 most dangerous areas in my web applications when I'm writing code. That's great, but don't stop your efforts at that. And in order to do that, we were looking at the kind of vulnerabilities which could be equated in terms of their danger or in terms of their risk. So that's the reason we decided to go with these 3 as as a sample more than anything else. There could be more, there could be maybe 5 more, there could be 10 more, but these 3 came extremely close or very similar to the danger posture that's reflected by the OWASP Top 10 list.
All right, thanks for that. Now the next question I have is, do you have any recommendation for a vulnerability assessment tool?
No, we don't have a recommendation of one tool over the other, but what we do highly recommend is that vulnerability assessment as a process has to have a combination of both using some sort of automation through tools and additionally making sure that there is some level of manual verification effort that happens. And to that effect, my current employer, which is Security Compass, we do have vulnerability assessments and even penetration tests as part of our advisory service offering.
All right, this next question I have here is asking about security requirements here. It says, tying back vulnerability data to security requirements doesn't seem intuitive. Can you elaborate on that a little bit?
I sure can. So that's a very good question because, yes, just by deduction, it will not seem very intuitive that you would be able to tie back any vulnerability data that comes through, let's say, your scanners. You have vulnerability scanners, or you're doing manual vulnerability assessments, maybe in-house, maybe you're doing them, getting them done through a third party. Just tying them back to security requirements doesn't seem intuitive. Why is that? Because usually all this data is in reports. And when it comes in reports, more often than not, what organizations would do is that they would consume these reports manually, then tie this data back into their bug tracking systems. And once they are in their bug tracking systems, then they will eventually look at how can this go all the way back to the developers in their organization, and whichever ALM tools are being used, which is the application lifecycle management tools. How do I get it back to the developers? All of that process ends up being manual. And the way Security Compass automates that process or helps automate that process is that we can actually help you take this very data, make sure that it flows back to the developer's ALM in an automated manner. And once that automation is achieved, essentially what happens is that for your subsequent releases, let's say this is the first time that you are exploring using SD elements, then for your subsequent releases, you will find that whatever was found as part of the vulnerability assessment or whatever data came out of that, that can actually be consumed, and your subsequent releases will have that as a security requirement. So you know that the effort that was spent in the previous release and whatever finding was there, whatever vulnerability was there, that would not show up in your subsequent releases, which is how your overall security posture of the application that you're developing will improve.
All right. Thank you so much for answering those questions and for sharing all that helpful information during your presentation. Now, right now, I'd like to ask everybody to visit the virtual expo hall where you can visit the Security Compass booth. You can chat with our sponsors and also network with other attendees. Many thanks to Vishal and Security Compass for joining us today and sharing all that great data. And, of course, thanks to all of you for tuning in.